Good morning, students. Let's start our class now. As I informed yesterday, that today we will be discussing what about the doubts you have in the DPPs I have given so far. And I got two replies, one from Mohor that you have three questions of similar type from DPP 14
14.
of integral calculus. Am I right, Mohor?
Yes, yes.
And I got another, email from Sagnik, where you mentioned that you have the last question from DPP 14 of integral calculus, right?
Yes, sir.
Okay, so anyway, let me start with those four questions, and then we will discuss if you have any other doubts. And I also got one information from Mohor that you have doubt in one of the question on the assignments what I had given, right? The last one.
Yes.
We will discuss all this today. After that, we will practice more leveraging transformation, substitution, and byparts. So this is the agenda for today's class. So I hope all of you are able to view the digital screen clearly.
Yes.
Okay, so the first question what we can discuss is that the question what raised by Sagnik, that you raised a question on integration of x sine inverse x. That was the last question, right?
Yes, sir.
Clear, no? So what is the question what he raised? So integration x sine inverse x dx. So now Sagnik, do let me know which one is the first function and which one is the second function.
So first should be sine inverse x.
Fantastic. Very well said. Sine inverse x. I hope all of you agree. Sine inverse x integration x dx minus integration ddx of sine inverse x into integration x dx, then complete dx. Right or not?
Yeah.
Then what we get? Then we know integration x dx is x square by 2. So x square by 2 sine inverse x minus integration x dx is x square by 2 and ddx of sine inverse x. Sagnik, I want to know from you. Dear Sagnik? Hello? Able to hear me? Okay. No? So x square by 2 into square root of 1 minus x square dx. In case Sagnik you are not able to hear me, you can follow it later. So plus c1. So then what we get? We get is that x square by 2, x square into sine inverse x by 2 minus 1 by 2 integration x square dx divided by square root of 1 minus x square plus c1. Hello Sagnik, you able to hear me?
Yes, yes, my mic was off.
Okay, it is very important that you hear. So now I hope you able to proceed till this much.
Yes, I got it.
After that what happened? Let me understand the problem.
So I got stuck with the second part of the derivation.
So you are talking about that you got stuck here.
Yeah.
This integration.
Yes.
Okay, so now this integration, what comes to our mind? It could be either transformation or substitution. Correct or not?
Yes.
Because the integrand, what is the integrand here? X square by square root of 1 minus x square, which is not directly integrable. So based on the knowledge what we have, either it should be substitution or transformation. So let's say that what kind of transformation we can make. Anyone has any idea? So if you do not, always remember, and that is also you can gain that what I'm going to say by a practice. Whenever you get this thing that x square 1 minus x square, you can always think of that whether can I put x equal to sine theta or cos theta. So let's take x equal to sine theta. It doesn't mean that, sir, x equal to sine theta that you put, but it is not the point. Point is that how I can keep if this kind of situation arises. Got it, no? That is most important. So what I'm telling is that why I'm choosing x equal to sine theta, because I know dx will be cos theta, and that is in the numerator, and denominator also square root of 1 minus sine square theta is cos theta, so that will get cancelled. If you remember in the last few classes I said that you need to think 1 or 2 steps ahead, because what I'm going to gain out of this substitution. But if you say no, I want to give a substitution x equal to tan theta, you are not going to gain anything out of it. But if you put x equal to cos theta, then also fine. Then also you'll get the same thing. You'll get. Dear Sagnik, did you get my point, what I'm saying?
Yes, sir.
So dx equal to what? Cos theta d theta. So then what we are going to gain? Integration x square dx divided by square root of 1 minus x square is equal to integration x square. X square is equal to what? Sine square theta. Correct or not? Sine square theta
Yes.
into dx is what? Cos theta d theta divided by square root of 1 minus sine square theta is equal to cos theta. So what we get? So this is actually coming as integration sine square theta d theta. So this is one round of substitution. We come up to a position, okay, it is good set. Then if you recall the transformation of trigonometric functions, then we need to express this in terms of what? That multiple angles of cos 2 theta. Correct or not? Now, how we can express sine square theta in terms of cos 2 theta? If you recall the trigonometric functions formula, sine square theta is nothing but 1 by 2 into 1 minus cos 2 theta d theta. Correct or not, dear students? That is equal to 1 by 2 integration 1 minus cos 2 theta d theta. And that should not be very brand new to you as well. Sagnik, am I right?
Yes, sir.
We have done this thing, right? D theta minus cos 2 theta d theta. How we have done? We have not done by means of this kind of original problem x square by 1 square root of 1 minus x square. But I recall that we have done integration of sine square theta d theta, cos square theta by 2 d theta we have done in one of our previous classes. If you recall, if you flip through my previous class notes, you will get one problem we have done, integration of cos square theta by 2 d theta. So then what we get from here? This is equal to 1 by 2 integration of d theta is theta. Now tell me what will be the integration of cos 2 theta? Sagnik? Integration of cos theta, that is equal to
Cos theta plus cos theta sine theta.
no, not at all. Sine 2 theta by
2.
correct, and you can add another integrating constant, suppose C2. Now you may think that okay sir, I forgot how to do integration of cos 2 theta d theta. No problem. You can make a substitution here. What substitution you can make? You can assume let 2 theta equal to t. Then integration cos 2 theta d theta should be equal to integration cos t dt equal to t by 2, d theta equal to t dt by 2, na?
Mhm.
So 1 by 2 will come and it will be dt.
Mhm.
So 1 by 2 into cos t is what? Sin t. Now you apply, revert back the value of t, that is sin 2 theta. That's what we have written here. Now, whatever I have done in this one, this you should be now matured enough to do by your, okay, it is so simple I can do. Correct, no?
Yes, sir.
So then what we get? So we need to finally revert back the value of theta 1 by 2. What was theta? Theta was our assumption. What is theta? Theta is equal to sine inverse x, isn't it? If x is equal to sine theta, theta equal to sine inverse x in simple term. We have not discussed inverse trigonometric functions, but at least we know this thing, that if this is the case, we can simply, make sure that this implies theta is equal to sine inverse x. Correct, no? So that value we need to apply back here, sine inverse x. So this is equal to sine inverse x minus 1 by 2 into sine inverse of, okay, sine 2 theta. So one thing we can do is that, instead of writing sine inverse x, we can make it little simplified here. Sine 2 theta means what? 2 sine theta cos theta. Let's find the value of sine 2 theta here. In terms of x, let me use a different color so that you can differentiate later. So sine theta equal to x. So that implies cos theta equal to what? Square root of 1 minus x square. In simple terms, it is plus minus, but we are just considering, we are concentrating on integration, so we take the plus value. Now what is sine 2 theta? Is equal to 2 sine theta cos theta. So this implies sine 2 theta by 2 is equal to sine theta cos theta. Sine theta is x and cos theta is square root of 1 minus x square. This value what we got, no, dear students, we are actually applying back here. Where? In the here. Correct? And sine theta by 2, what we are going to get? Sine theta by 2, we are going to get, x into square root of 1 minus x square. So let me remove this thing. So it will be x into square root of 1 minus x square plus c2. Agni, is it perfectly fine? Completely understood? So now that value of integration of x square dx by square root of 1 minus x square, we can again reply back here. Correct? Here we can write. Then what we are going to get? We are going to get the value of the integration as x square into sine inverse x by 2 minus 1 by 2. Actually, you can write minus 1 by 4, isn't it? Minus 1 by 2, and this 1 by 2 will come, na? This 1 by 2. So it is minus 1 by 4 into sine inverse x minus x into square root of 1 minus x square plus I'm writing the integrating constant as c, where we are adding c1 and c2. Correct? So this is the value of the integration. Any doubt?
No, sir.
Absolutely clear, right?
Yes,
Yeah.
sir.
Perfect. Now let me come to Mohor's questions. Dear Mohor, please do let me know what questions you have from the DPP 10.
Well,
Or
the first,
directly tell me what is the integration so that I can do accordingly.
Yeah, it's integration of 1 by e to the power x minus 1 dx.
Okay, I do understand. So your question,
This is the first question of the
yeah, I think you talked about this thing,
yeah.
integration dx by
Dx
power
by
x
e.
minus 1.
Yeah,
Correct, no?
yes, yes.
So even I had the same doubt.
Okay, okay, Gurman. Now, point is that whenever we get this kind of question, so also it is a hint was given, right, that you can apply e power x equal to t, correct or not?
Yeah,
Hmm.
yeah.
So this is a very classical question, good question. In fact, it is okay that you have not you tried and not able to do mm, by this time, because there is a particular concept I didn't discuss, and at the same time, it is quite you know easy to do this thing, because that particular concept is called partial fractions. But the very fundamentals of partial fractions you can do. So I can, good, thanks Mohur for raising this question, and Gurman as well. So I can discuss this one. So what the assumption here is that let e power x equal to t. This implies e power x dx is equal to dt. Anyone has any doubt here? Because we know differentiation of e power x is e power x, correct or not?
Yes.
So then what we are getting is that dx is equal to dt by t. All of you agree to me?
Yeah.
Power x is t. So what we can write, this integration is now transformed to, because of this substitution. After substitution, what we get here is that it is t into t minus 1. And I hope after that you got the problem, correct, na, Mohar? I
Yeah.
assume that after that you got this problem, correct?
Yes, I got it afterwards, but I had to take help from my mother. I couldn't think that.
Okay, appreciate, good. Now after that what we can do is that, if you see that now what is the integrand here? 1 by t into t minus 1, correct or not? So we can express in terms of like this, that if we write like this, 1 by t minus 1 minus 1 by t. Do you agree to me? This is becomes 1 by t into t minus 1. If you
Yeah.
simplify the right hand side, did you get the left hand side?
Yes.
You get, but you can answer how you have done it. That is a very valid question that I will discuss. Let me first explain you why we have done so. Because we know that we can integrate integration dx by x, and that is ln x, correct or not, dear students?
Yes.
A log. So let me first complete, and then I'll come back that how I can write that 1 by t into t minus 1 is equal to 1 by t minus 1 minus 1 by t, and if something else is given, then how I can express. If anything bigger is given, if it is given 1 by t minus 2 into t minus 3 into 2t minus 5, how I can express, like, the sum or difference of the reciprocals. Are you getting me? Did you get my point, what I'm talking about?
Yes. Yes. I get it.
That I will discuss with the help of this solution. So what we are getting here is that, so then ultimately the integration comes as dt by t minus 1, correct or not?
Mhm.
Minus integration dt by t. All of you agree to me, dear students?
Yes. Yes.
Gurman, got it?
Yes, sir.
So now tell me, Gurman, what is the integration of dt by t minus 1?
So it will be the integration of t minus 1 to the power minus 1.
No, not at all. What is the integration dx by x?
Log of.
Exactly. It is a ln of x, right?
Yes, sir.
It should be ln of, think about, before giving the answer, you should think that what I'm answering. And sometimes we may say, no, I cannot answer, I cannot recall. That is also fine. But how come this statement comes? Integration of x to the power n dx is only valid when n is not equal to -1, right?
Yes, sir.
Minus ln of t, got it?
Yes.
Plus integrating constant c. Gurban, any doubt here? T minus 1, t minus 1, we need to write e to the power x minus 1, correct or not?
Yeah.
Minus ln of e to the power x plus c. We can further simplify that log m by n, log m minus log n is log of m by n.
Yes.
So that is e to the power x minus 1 by e to the power x plus c.
Yeah.
Correct, no? So that is the value of the integration. Dear Gurman, do you have any doubt here?
No, sir.
Okay. So now I would like to explain that how we get this thing, how for any other partial, this is called partial fractions. So integration of partial fractions, that we will have a complete dedicated class for that, but I'm just giving a hints. And if you remember that few minutes back I said it was not that difficult. You can do this thing by your own also without knowing the proper mechanism of partial fractions, isn't it? Whatever I've done it here.
Yes. Yes.
Just a simple intuition of applying that your algebraic manipulation. But why we should do that, that should be that I answered that we should be doing, because we need to make sure that we are doing the, and that if we make in a sum or differences of reciprocals, those individual reciprocals are very easy to integrate the way we have done. Integration dt by t minus 1 is very easy to do, ln of t minus 1.
Yes.
Integration dt by t is very easy to do, it is ln of t. But we are not sure that what is the integration of dt by t into t minus 1. That was difficult. So how to do this thing? So the normal way of doing this thing is that we should write this is equal to a by t minus t plus b by t minus 1, when both the expression in the denominator are linear. Linear means t is a linear expression, correct or not, dear students?
Yeah.
And t minus 1 is also a linear expression. So when there are multiple linear expressions are multiplied in the denominator, okay, and numerator is also a linear expression, one linear expression or less than that, then we can write like this: a by t plus b by t minus 1. What is a and b? Here the a and b are real constant that we need to find. So that means what? Our purpose is to find the value of a and b, correct or not? By applying our intuition, we found the value of a as -1 and b as +1, correct or not, if you look into here?
Yes.
But how we get it? What is the process? That process is called the partial fractions. So from here, and this is an identity. Identity means what dear students? So here a and b belongs to the set of real numbers. Identity means it is true for any values of t, both left hand side and right hand side will be equal. For whatever the value of t you consider, okay, you will always get the value of left hand side is equal to the value of right hand side. So now if we simplify, what we are going to get? Left hand side it is 1, right hand side it is a into t minus 1 plus b into t, correct or not?
Yeah.
Now we are applying the value t equal to 0. If we apply the value t equal to 0, what we are going to get? Left hand side is 1, right hand side is a into 1 minus 1, correct or not?
Yeah.
Plus b into 0.
So it was 0 minus
0 minus 1. You are absolutely correct. It should be 0 minus 1. Correct. So from here, what is the value of a we are getting? Minus 1. And then next value we are applying t equal to 1. Then left hand side will be same 1, correct or not? Right hand side should be a into 1 minus 1 plus b into 1. So what is the value of b we are getting? Plus, correct or not, dear students?
Yes.
So then what we get? We get that same, expression. Now we can represent as a 1 by t into t minus 1. A is equal to minus 1 and b is equal to plus 1. So let me write first b, because we prefer to write plus thing first, na? Minus 1 by t. This is exactly what I wrote in the red color here.
Yes.
Correct, na? Here.
Yes. Yes.
But I explained what is the process of doing this thing. But what process you should follow. Got it, no?
Yes.
And we will have a dedicated class later that how to use partial fractions, okay, and perform integration. Then you can ask, sir, then why you gave this question? This question I gave intentionally because you don't need to have a very rock solid understanding of partial fraction to solve it, isn't it? It is just an intuition that you can always think of, that 1 by t into t minus 1 is nothing but 1 by t minus 1 minus 1 by t. For that, you don't need to have the detailed knowledge of partial fraction. But one point should come. But then another reason why I gave is that whenever you get this kind of point, that 1 by t into t minus 1 or similar to this, always you need to think that my purpose for integration of this one is that I need to make a sum or differences of individual linear expressions, where the in the denominator is a linear expression, so that it will helpful to me to perform the integration. Okay, if Gurman, dear Gurman, everything is very clear.
Yes.
Okay, Disha, Srijita, Divansu, things are clear.
Yes, sir.
Okay, great.
Yes.
Okay, great. If it is clear, then let me proceed to the next question. Mohor, what you have? Please do let me know you can directly tell me the question number or the integration. What the integration you have doubt with?
Integration of x dx by
Integration of, okay. Integration of x dx by x minus 1 into x minus 2. That's what, no?
Yeah.
Okay, sure. Same concept. Okay. I just give you the hints so that you can proceed. So here the question what you have is that integration of x dx into
x
minus 1 into x minus 2.
Yeah.
Here also, if you just apply, kind of your basic intuition, okay, that how I can express this in terms of, reciprocals, okay, sum or differences, okay, of linear expression. Just think of, if you just play in your, your knowledge of algebra, you will get something like this: 2 by x minus 2 minus 1 by x minus 1. Correct, na?
All right. Yes. Yes.
Think of all of you, dear students. The moment it is so easy. Correct? Performing integration becomes so easy. So it will be what? 2 into ln of x minus 2 minus ln of x minus 1. Done.
Yes.
But I want to show you how we have done it despite not having the proper knowledge of partial fraction. I just showed you, right? Now I'm going to show you that how we can apply the knowledge of partial fraction to do this thing. Okay, dear students. So how to do this thing? So here is the process. So how we are going to write? So when numerator is a linear expression and denominator is a product of linear expressions, what we are going to write? We are going to write this is equal to a by x minus 1 plus b by x minus 2. Correct or not, dear students?
Yes.
Where a and b are real constant. They belong to the set of real numbers and they are constant as well. So from here, what we can get? X is equal to a into x minus 2 plus b into x minus 1. Now this is an identity, as I said in the previous question. Identity means both left hand and right hand is going to be true for any value of x, any real value of x. So I choose the value of x equal to 1. If we choose the value of x equal to 1, what we are going to get? This implies left hand side is 1,
Then A
right hand side
minus
is 1 minus 2, and b into 1 minus 1.
0.
This implies a is equal to minus 1.
Yeah.
Correct or not, dear students?
Yes. Yes.
Now next one, I will choose the value of x equal to what? Can you tell me? 2, correct?
2.
So this implies what? Left hand side is 2. Right hand side a is equal to 2 minus 2 plus b into 2 minus 1. Correct or not? This gives the value of b is equal to 2.
Yeah.
And exactly same thing what we achieved here. Now, if someone of you
Yes.
have a query in back of your mind but not able to express or whatever, or maybe the question didn't come, you may think that, sir, you said I can choose any value of x. Nah? So then why you choose 1 and 2?
It becomes 0,
Correct.
like one of them. So then we can find.
But you know, if you took any value of x, suppose I want to choose the value of x equal to 3, then what is going to happen? Then 3 is equal to a into 3 minus 1, 3 minus 2 plus b into 3 minus 1. Correct or not? So then what we are going to get? A plus 2b is equal to 3. And suppose you choose, sir, I choose x equal to 4. Chalo, no problem. So 4 is equal to a into 4 minus 2. Correct or not? Plus b into 4 minus 1. So this implies what? 2a plus 3b is equal to 4. Now you need to solve these two linear equations. And you will get the exactly same value of a and b. Now the point comes, because why I explain this thing, because this is important so that you know that how I can reduce time. If you solve these two linear equations, you will get the exact value of a and b, a equal to minus 1, b equal to 2. Now it is a matter of which one I want to prefer so that I can reduce the time. Here I am not going to discuss linear equations, how to solve linear equations. Here we want to do integration. That's why we need to do shortcut. Correct? No?
Yes.
Once we get this thing, dear students, then it becomes pretty simple. So this becomes what? Integration 2 I can take outside to integration of dx by, let me do, because there is a small step you may need to understand how to simplify, minus integration dx by x minus 1. Isn't it? Divanshu, able to follow very clearly?
Yes, sir.
Okay. Disha?
Yes, sir.
Great. And you know, dear students, one very important point, all these things will come when you will be in the next year. When you will be in class 12, please save all these things, all these notes, all my video lectures, you know, all these recorded lectures. Please save. It is there in YouTube, but you please save it to it in your folder so that when the next year will come, you just open up. You don't need to consult anyone. You don't need to consult myself also. Okay. You'll get all the idea. You'll see that yes, this is a very good discussion we had a year back. After 1 year, you will think this. So then what we are getting? We are getting ln of x minus 2 whole square. Correct or not? We know a log m is equal to log m to the power a minus ln of x minus 1. Correct or not, dear students?
Yes.
Plus c. So this is equal to what? ln of x minus 2 whole square by x minus 1.
Yeah.
If anyone has any doubt in this, expression of logarithm, please ask me. Because we know log m minus log n is equal to log of m by n.
Yes.
Correct, no? So eventually, this question was a multiple choice question, and we see that option B is correct, no? Mohan?
Yes.
Okay. Please do let me know your next question.
Yeah, that is integration of dx by x into x square plus 1.
Very good. Fantastic. Let me do this thing. That is also why I'm saying it is fantastic, because
It's not linear, the second.
this is not linear. So, and I got an opportunity to explain you that how to do, apply a different concept of, it is a different case of partial fractions. Okay, so let's proceed to this question. And tomorrow we will discuss that partial fractions in details. Okay, sure. This is question 4. But discussing this kind of, small, simple questions today makes a lot of sense. Integration dx by
X into x square plus 1.
x into x square plus 1. You may think, sir, if it is instead of x square plus 1, if it is x plus 1, I do not need your help, sir. I know by this time how to do. Correct or not?
Yes.
Because both are linear expressions. But as it is, one of the expression in the denominator is a quadratic, means not linear, then, sir, you need to help me here. Because, so now, how we are going to do? And here also, as I said in the few minutes ago, that without having your knowledge in partial fractions, you can apply some intuition and this thing. No, it is difficult for a teacher also. You really cannot apply that intuition and come up with this thing. Possible, I can do it. But the best way of doing is that not to apply that one, better to go through the process.
Okay.
So what we are going to get, here it is 1 by x into x square plus 1. Correct, no, dear students?
Yes.
So always remember, when it is the case for the linear expression, I will write here a by x, because x is linear. So I will write linear plus denominator. Let me write it down. Whatever is there in the denominator, it is x square plus 1. But as the denominator is a quadratic expression, I should write in the numerator a linear expression, 1 less than the degree of the denominator expression. Denominator polynomial is having a polynomial of degree 2. So numerator I should express the polynomial of degree 1. So what is the polynomial of degree 1? Bx plus c. Correct or not, students?
Yes.
Absolutely clear.
Yes.
Okay. So let me repeat once more. When you have the denominator a quadratic expression, in the numerator you should write a linear expression. Now a is already chosen, so I am choose the other two constant as b and c. Correct, no, dear students?
Yes.
So what we see is that here a, b and c belongs to the set of real number. It is constant.
Yes.
So now we just concentrate on this linear expression. So left hand side a 1, left hand side is 1, right hand side is a into x square plus 1. Correct or not?
Yes.
Plus bx plus c into x. Bx plus c into x. Correct, no?
Yeah.
Now from here what you can write? I write 1 is equal to a plus b into x square, because both the power of coefficient of x square is a and b in the two expressions. Correct, no? Plus c into x plus a. All of you agree to me?
Yes. Yes.
Anyone has simplest doubt? Let me know. Now there is a fantastic thing. What I said, why it is fantastic, you'll understand in a minute. I said it is a identity. 1 equal to a plus b into x square plus cx plus a. So if if there is a x square in the right hand side, there should be a left hand side also x square. Identity, na? Identity means it has to be, true for any values of x.
Yes. Yes.
So that means hypothetically we can write something like this: 0 into x square plus 0 into x plus 1 is equal to a plus b into x square plus c into x plus a. Did you get my point, dear students?
Yeah.
So from here, now why I wrote like this? Now the coefficient in the left hand side should be equal to the coefficient in the right hand side of the like term. That means
Yes.
the coefficient of x square in the left hand side, which is 0, should be equal to the coefficient of x square in the right hand side, which is a plus b. So that gives what? That gives a plus b is equal to 0. Then what we get? C is equal to 0. Correct or not?
Yeah.
And a is equal to 1.
Yeah.
Correct or not, dear students?
Yes.
So now, if we apply all these things, what we are going to get? You are going to get the value of a is equal to 1, b is equal to -1, and c is equal to 0. Now you can ask, sir, it is the only one way? You only said few minutes back, as it is an identity, it is going to be true for any values of x. Yes, you can take that approach also. From here, you can apply the value of x. Let me use a different color and show you to this one. From here, what we are saying is that, let me take this thing, and you will get that exact same value of ABC. It has to be. So what we are doing here, that here we are applying the value of x equal to 0. Let's apply the value of x equal to 0.
Okay.
Then what you are going to get? Left hand side is 1, right hand side a plus b into 0, na?
Yeah.
Correct?
Yes.
Plus c into 0 plus a. You got now value of a is equal to 1, which you already achieved.
Yes.
Correct? Na?
Yes.
Then let's take the another value of x. Okay, you can take another value of x is equal to, suppose, you tell me, na? Suppose let's take the value of x equal to -1. Correct?
Okay.
X equal to -1. Then what is the value of left hand side? 1. So a plus b into -1 whole square is actually +1. Plus c. Correct, na? C into -1 plus a. Correct or not? So from here what we get? A should be there. 2a plus b minus c equal to 0. Correct, no?
Yeah.
2a plus b minus c equal to 0. And we already got the value of a is equal to 1, na? In the previous, when we put x equal to 0. So that means we get b minus c plus 2 is equal to 0.
Yes.
Now again you can apply value of x equal to, suppose 2. Apply the value of x equal to 2. So what we are going to get? You will get left hand side is equal to 1, right hand side is equal to a plus b into 2 square is equal to 4. Correct, dear students? Plus
2.
c into 2 plus a.
Yeah.
So from here what we get? So 4a plus a, 5a plus 4b plus 2c is equal to 1.
Yeah.
Okay, just a minute. I think I made a mistake here. In the previous one, 2a plus b minus c should be equal to 1. Na? It should be equal to 1, correct?
1.
Am I right, dear students?
What's to 1? Oh, yeah.
2a plus b minus c should be equal to 1. We know the value of a is equal to 2. So here it should be 1. Correct, na?
Yeah.
So this is, suppose I give equation 1. So what we get here in this next one is that 5a plus 4b plus 2c is equal to 1. So we already know the value of A is equal to 1. We already achieved, right? So 4B plus 2C plus 4 is equal to 0.
Yeah.
So we can take 2 common. So we get 2B plus C
C.
plus 2 is equal to 0. So that is equation 2. Now you can solve equation 1 and 2, find the value of B and C, and apply that. You will get the value of B is equal to minus 1, C is equal to 0. Correct, no?
Yes.
But the point is that why I didn't take this approach, because same logic, it is time consuming. But we should know, we should be aware that when there is a question on partial fraction, okay, pure question on partial fraction, not application of partial fraction to solve integral calculus, we should be knowing this thing in details. Correct, no, dear students? Correct?
Yeah.
Absolutely clear?
Yes.
Okay, so then as we find the value of A, B, and C, what we are going to do? So we are going to do here is that, what we can write, integration of A by X, na? So integration, let me use a different color. So this equal to what? Integration of dx by x, correct or not?
Yeah.
Plus bx plus c, b is minus 1, c is 0. So that means I can write here is that, it is minus c is 0, integration b is minus 1, so that minus I took out. So x dx divided by x square plus 1. Am I right?
Yes. Yes.
Clear or not clear?
Yes. Yes.
So then what we are going to do is that we all know that how to find that integration dx by x is ln x. But how to do the integration of this thing? Anyone can give any idea, please?
We can take x square plus x square equals to t.
Yeah, we can take x square equal to t, but I will prefer to take x square plus 1 equal to t. Let me tell you why. Sure. I will prefer to take x square plus 1 equal to t. But Mohor, if you take x square equal to t, then also you'll get that solution. But again, our purpose is to do things in a simple manner. So then what happened here is that 2x dx is equal to dt, correct or not?
Yeah.
So then this entire integration of x dx divided by x square plus 1 is turning out to be, 1 by 2 into integration dt by t. Correct, no? It is very simple to solve.
Yes.
What is that? 1 by 2 into ln of mod t plus, suppose one integrating constant c1. So this is equal to, we need to revert back the value of t. Ln of t is what? Mod of x square plus 1. By the way, here giving mod is not that meaningful, because x square plus 1 should be always positive, irrespective of the value of x, any real number, correct, no? So then this thing, sorry. Okay. That value we can apply back here. Now, let me tell you that what will happen if you take, as you said, x square equal to t. Let me not take t, let me take it is u. Okay. Let me use a different color. Correct, no?
Yeah.
So if you take x square equal to u, so that means here 2x dx is equal to du. So integration x dx divided by x square plus 1 should be equal to what? 1 by 2 into integration du by u plus 1. That becomes what? 1 by 2 into. So now when we assume x square plus 1 equal to t, we got t square integration dt by t. It is so simple, ln of mod t. Here also, it is ln of mod of u plus 1. Plus 1 integrating constant, suppose c2.
Okay.
You need to revert back the value of x square u plus 1, na?
Yeah.
So now it is 1 by 2 into ln of x square plus 1 plus c2.
Yes.
Now it is self-explanatory which substitution is preferable.
Yes.
I think I don't need to say, correct or not? It is, you understand which one is.
Yes.
Correct? So now,
Yes.
once you find all, find all these values, after that, what we are going to do, we just take from here, correct or not?
Mm.
That is equal to ln of mod x minus 1 by 2 into ln of
X.
mod of x square plus 1, and one final integrating constant I'm writing as c.
Yeah.
Correct, na, dear students?
Yes.
And that becomes your final solution to the question.
Okay.
So tomorrow, we will have a very detailed discussion on partial fraction, the motivation behind partial fraction, why you should apply partial fractions in details.
Okay.
Anyone has any question on the DPPs? And Mohur, the question what you have on the assignments, that I will assist you after the class. Okay.
Okay, sir.
Fine. No? I'll guide you. You'll be able to do it by your own.
Okay.
But
Yes.
if one has any doubt in this, any of these questions in all these DPPs, please do let me know. If there is no such question, I would like to conclude the class now. For the assignments, I want to spend separate time with individuals, okay, to discuss your own solution.
Okay.
Okay. Any question, Debansu, Disha, Srijita, Gurman, Sagnik, Mohur? Any question you have?
Okay.
All fine?
Yeah. Yeah.
Okay. All right then. Thank you very much. We will have our class tomorrow at 9:30 a.m. Okay.
Yes.
All right. Bye.
Thank you, sir.